It's 4 minutes after. We'll start the spiel. We'll start the spiel, and then people can come in to learn about the RegEx. So, welcome back to Silicon Dojo. Authorityless, gatekeeperless, free to the end user, hands-on technology education that empowers you to do whatever the hell it is that you want to do. Basically, the idea here is, what if we took the concept of education that's been on YouTube and we create something, again, for the 2024 world. I started creating online content back in 2009. So online education, just creating a video and having it up there for you, is very 2009. So the question is for us old timers is, are you a boomer? That's what I ask myself every morning. I wake up in the morning and I go, Eli, are you being boomer? And here's the thing, if you created something 15 years ago and you're doing something the exact same way that you did it 15 years ago, you're probably a boomer. So anyways, the idea of Silicon Dojo is, hey, what if we had this interactive educational environment? So we have classes online. We do 2 of these classes online per week. We do a class in Asheville, North Carolina, once a week. We just had a class yesterday. And very soon we'll be having classes in Raleigh, North Carolina. And so it's kind of like this idea of what can we do, I don't know, whatever the hell that is. Many to single to many blob communication. We're creating a blob data type for education. Anyways, if you haven't been there, so there's a Silicon Dojo website, silicondojo.com. The big thing for coming here is there's a whole bunch of links. It's kind of ugly. I'm still working on it. But for classes, for upcoming classes, so it shows you the RegEx. We don't have anything past this yet. But you can go down, you can see the other classes we've had this year. So we had an introduction to hacking, we had Linux, we had intro to Python, web app architecture, form validation, REST APIs, and RegEx. And so the idea is you'll be able to come to the silicondojo.com website, and you'll see all the things that we're offering. And then you sign up for whatever it is that you want to offer. There is a member site to this, and there's a forum. You can sign up if you want to. There is a donor box link here. So again, Silicon Dojo is free to the end user. That's not actually free. It does cost me money to do this stuff. So if you'd like to throw in $5 a month, $10 a month, $1,000 a month, I will take your $1,000 a month if you want to support what we're doing here at Silicon Dojo. That sounds like a joke. We actually did get a $1,000 gift last week. So I'm just going to keep throwing out $1,000 a month. Like, I used to say, like, you can do $1,000. So we got $1,000. So now the question is, can we get $1,000 a month? Anyways, whatever you're willing to put in there. Again, if you find the education valuable, if you're able to throw some money in, if you want to throw some money in, please do. Let's see, GitHub, all the educational material is here for you to use. The notes, the VS Code, all that kind of stuff is on GitHub. There's a link on silicondojo.com for that. We also have the classes. 205. Oops. So anyways, I have a camera here for Zoom. I have a camera right there. That's 4K. And so that's recording the Zoom class. Basically, either tonight or tomorrow, there will be an uploaded version of this class on the Eli the Computer Guy YouTube channel. You can go and you can watch it. The 4K version is much better. Zoom video encoding is kind of crappy. If you want to follow me on LinkedIn, there is the LinkedIn account. There's a link on Silicon Dojo too. You can see, look, we had 3 people. We had 3 people in class yesterday here in Asheville. Yay! So anyways, you can see what I'm doing on LinkedIn. And again, as I say, for the meetups now, so we have 3 different meetups. So we have the online meetup, what you're watching. We have the Asheville edition. Again, this is in person in Asheville. And we have the Research Triangle edition. That is coming sometime next year. If you are in the Research Triangle, just so you know, if you care, I will be going to All Things Open, the meetup, next week. So again, I'm trying to do the research and all that for how to do these classes in Research Triangle. So ATO is having a meetup, so I figured I'd go to it. So I will be in Durham at this thing. Again, if you're in that area, I highly recommend you go to the ATO meetups. They are great. And golly, I guess that's it. Oh, do we gotta do it? Mommy, do I have to? Do I have to do RegEx today? I just don't want to do it. Anyways, this is one of those classes we just got to do. This is one of these classes you got to do. You're going to hate it. I'm going to hate it. You're always going to hate it. But you got to learn it. But you got to learn it. So we are going to. It is funny, we talk about RegEx. When we say RegEx, we're talking about regular expressions. And this is basically the idea of being able to pull information out of strings, a string data type, basically following patterns. So you put in a pattern, and it'll fail. And then you tweak the pattern and it'll fail. And then you tweak the pattern and it'll fail. And then you tweak the pattern and then you swing a dead cat over your head about 20 times and then it'll work for some reason. And you're like, Eli, that's ridiculous. That is absolutely ridiculous. Why would it matter that you swung a dead cat over your head 20 times? I don't know. Just something about dead cats. Swing them over your head. Sometimes it makes your regex work. But anyways, all it is you create a pattern in order to pull out values, essentially, from text strings, and that's what regex is. Regex is kind of weird. Again, in the Sys Admin world, there's something called subnet masking, again, creating a custom subnet mask. And any sysadmin you talk to, if you tell them they have to create a custom subnet mask, they will cry like little babies. I will too. It's not them, it's all of us. I don't know why. Subnet masking really isn't that big a deal. Frankly, you can go Google it nowadays anyway. But it cry. I don't know. They're just doing a subnet mask makes every sysadmin cry. The curious thing about regex is basically the same thing in the programming world. You talk to programmers about regex, and then there's just like a little part of their life that seeps from their soul. I don't know what it is, but it is true. So anyways. If you're watching this class today, if you're participating, and you're like, I feel like my soul is being sucked away from me. Don't worry. That's what regex does. I don't know what else regex does, but it's very good at destroying your soul. So anyways, we're going to talk about regex and data parsing today. So what are we talking about when we're talking about parsing? Parsing is basically where you have your computer program reading text information that it gets from somewhere and then being able to do something with it. Again, it may be parsing the information in order to do something like fire off a function, a time function, a weather function, that type of thing. It might be pulling information out so it can throw it into a database, that type of deal. It might be pulling things like email addresses out so it can fire off emails, notifications, that type of thing. Basically, all we're talking about when we're talking about parsing is we're talking about the ability for your computer program to be able to read information, and then you can do whatever it is that you want with that information. The first thing that I want to talk about is grep. So again, when we start talking about technology, again, with all this stuff, it is important to remember to think about your systems in layers, and the whole question of, can you Anyways, can you pass off tasks to a different system that might be able to do it more effectively, right? Like, so when you're dealing with Python, you're dealing with your database, if you're doing any transactions in the database, most likely the database server will be able to process the transactions in a lighter resource requirement way, in a faster way than if you did it in Python, right? So you pull all this information from your database into Python, and then you could sort it or do whatever else in Python, but that's going to require more resources out of your system. It's going to be slower. Again, at scale, it's going to matter. So one of the things to think about is, hey, can we push all of that work off onto the database server so that the database server does it? It will most likely be able to do it in a faster, less resource intensive way. Again, one of the things to be thinking about, again, as a real technology professional, is your job is to figure out how to be as lazy as possible. How can you shove work into somebody else's world? And that's where a lot of arguments start. I think your systems would be more effective at doing whatever it is that we're doing. So anyways, right, so we're talking about that again, like we're talking about data parsing now and all that kind of thing. So again, you have your script here, again, you have your Python script, and then it's going to make a call to something, right? It's going to make a call to a SQL server, it's going to make a call to your OS, it's going to make a call to the API, whatever else, right? And then the response that comes back will be a string of data. It may be this big, it may be a book, quite literally, and then your Python has to read that data. And so the thing is, right, Python is our little baby. We don't want to make it do any work. It's our pride and joy. So one of the questions is how can we pass off as much work as possible to something else? And so that's one of the things a tool called grep is useful for. And so what basically grep allows you to do with the Linux operating system, or Unix operating system, it works on Macs, so we're going to show you on a Mac, is it will return, oh, there's two purples. Which purple to use? Anyways, it will return, when you make a request, it will return only the lines that contain a specific thing that you care about, right? So let's take a look at this. So again, grep. So grep is just a command within Linux. It should be there, right? So let's say we want to do a ping. We want to do a ping, and let's say we want to know latency. Right, so latency is the speed it takes to go from you to there to there to there. So I want to know like what the latency is. So let's say I'm trying to ping my VoIP servers. There's getting jitter. There's jitter on the line, and it seems like, I wonder if that's a latency issue. So I want to ping, and I just want the latency information, right? So again, if we go to the terminal, right? So we go to the terminal. Let me increase this a little bit. We go to the terminal, and so I do ping, and I do count of 1 to CNN.com, and then I ping. It's like, oh, that's a lot of information to read. That's a lot of information there, right? So I ping, so it gives me the response back when I ping CNN.com. It's going to give me this is what the IP address is. It's going to give me the time to live. It's going to give me some other statistics. It's going to give me a lot of this information. And I'm sitting there, I'm like, oh, you know what, that's a lot of information. So what if I can grep it? What if I can grep it? So I'm sitting here and like, what do I care about? What line here do I care about? I don't really care about the IP address. I don't care about the bytes. I don't care about the packets transmitted. Again, I want latency. So if you don't know, anyways, we had a whole class on this kind of stuff before. Anyways, latency is this particular line. It's showing you the low, the high, and the average time for the latency for the packet. So 32.270 milliseconds is the latency. So all I want is this, right? So what I can do, I can type in clear. So I can do ping, count of 1, CNN.com. I pipe it. It's called piping. Through grep, so I'm going to use grep, so I'm going to do this, send this to the grep command, and then I'm simply going to ask for a forward slash. I always get that messed up. So basically, only give me a line with a forward slash in it. So I hit enter, and now we can see now all we get is the one line that has the forward slash in it, and so again now I see that it's 30.14 milliseconds. So again, if I'm creating a little app that's trying to track things like latency, now when this comes into the Python, instead of having to sort through 8 lines of response, I am now getting this single line of response. Again, I can go here, and instead of doing the forward slash, let's say I do the equal sign. When I do that, I get 2 things back, right? So 64 bytes from, this is the IP address, ICMP equals 0, time to live equals 56, and time equals 31.417 milliseconds, right? And then I also get the round trip. This is the averages here. And so basically that's all we're talking about with grep, and so this can be very useful, again, when you're sending those commands to the operating system, basically be able to pull out that type of information. Beyond that, let's see here. Oh yeah, like with inet, this can be very useful for you, like with Mac, right? So I do ifconfig. So let's go here. Like one of the issues you can run into. So the grep is a great tool just generally, right? So ifconfig. So ifconfig on the Mac basically will give you information about your network cards, right? Well, here's the thing. Back in the day, we used to have 1 or 2 network cards on your computers. Back in 2000, we did networking the right way. There was like 1 network card on your computer. If you do ifconfig now, you're gonna get so much crap back. You're gonna be like, what? What is this garbage? And basically, you're gonna have to go through and you're gonna figure out what the hell it is that you're actually looking for. So the cool thing is, grep inet is you can do the grep thing. So let's say I want the IP address. Again, from the command line, because I'm going to pull this in with Python, I want the TCP/IP version 4 IP address, right? So I can do ifconfig. I can pipe this bad boy through grep. And then I can do, I think it's inet space. Again, so you can do double quotation marks, so it puts a full thing in. I do believe it's inet space to get you what you're looking for, and I hit enter. Yay! So basically it shows me inet space, so 127.0.0.1. Obviously that is my loopback address, and inet space 192.168.1.36. So this gives me what the IP address of this particular computer is. Again, if I needed to do something with it with the server. So again, imagine if you're writing your Python code. Again, imagine if you're writing your Python code. What do you want to deal with? When you're writing code to parse, do you want to deal with this mess? Do you want to deal with this mess? Or do you want to deal with 2 lines of code, or 2 lines of response? And so that's one of the things that you do with grep, is so basically you're pushing basically that kind of responsibility onto the operating system so it can do it more effectively. One of the interesting things with grep is you can actually read text files with it. So grep is a command on its own. So what I'm going to do here is this ping c1cnn.com, and I'm going to send the results to ping-result.txt. Again, this can be a very useful thing when you're dealing with the operating system, especially if you're dealing with commands that take a little while. So ARP --A, right? So ARP, Address Resolution Protocol, it resolves MAC addresses to IP addresses. When you do the ARP --A command, it can take a little while, right? So especially if you're trying to do parsing or whatever else, you don't necessarily want to wait for that every time it goes through. So one of the things you could do is you could simply output it into a text file, and then you could read that text file. So that's what we're going to do here. So I'm going to go and clear. So I'll do Control V. Oops. So I'll do ping count1 cnn.com arrow thing to ping result.txt. Alright, so basically the result of this command is going to go to that text file. I hit enter. You don't get anything else because everything got outputted there. If we go over, we take a look. We go to my root directory, so we go to Eli. We're going to see there's a new file here, ping-result.txt. We open it up, and wow, we get the results in a text file. Woo! Anyways, so the important thing here, though, is that you can use grep. You can use grep to then read that text file. And so this can be very valuable. Again, so I'm just doing the ping command here because I'm not very creative, but this could be a book. Right? This could be 1,000 pages of text. And all you care about is any line in that 1,000 pages of text that relates to something very specific. Right? So you can do the grep command. You say what it is that you're looking for, and then you say what text file, what ASCII, UTF-8 file you want the information from, and then it'll give you the results. So if we go back, so if I do grep, I say I'm looking for the / out of ping-result.txt, and it will give me my nice little information for what my latency is, right? And so basically that's how you can use grep. So grep allows you to pull specific information directly out of the response, directly from the operating system, or again, you can feed it a text file. And this will become a bigger deal as we do larger projects. So there's something called Nmap. Nmap is like a network scanning utility. It's a ping sweeper, plus it does a whole bunch of other stuff, but it gets so much information. Like you run Nmap, you run Nmap with all this, and it'll take 2 hours, and then it just pulls back a tremendous amount of information. And you can dump it into a text file. And one of the problems you have is, again, just how do you read all of that information? So one of the things you can do is you can just use grep. And with grep, you can pull out the specific information that you care about from that file. Jock had his hand up. Is Jock even here anymore? No, Jock is still there. Okay, Jock put his hand down. So I guess I said something. Witty and wise. Okay, so that is what we're talking about with grep. Any questions on grep? Okay, Jock is there. What's up, Jock? Or is he there?
I want to get an idea. grep is used to, again, I'd step away for a minute. You might say this. So we've talked about the grep command before. grep is used to pull out data to talk about the operating system that you're asking about, not exactly the website or the information that you're pinging. So you did CNN.com and you're just pinging a package. But if you want to know more information about the operating system that the server is on, that's what you use the grep command for? Am I understanding that correctly?
So grep can essentially read any text and it will return any line in that text that has what you're searching for. So it returns the entire line.
Okay, I'll come back to you.
All right, so like when you do the ping command, right? So I do the ping C1 CNN.com, right? So you get all of this stuff back. So you get CNN.com, you get this. Anyway, these are all word wrap. And again, if you guys don't know, it's just called word wrap. It's word wrap, don't be scared. It's all actually on one line, right? So okay, maybe that makes more sense here. So all this is just on one line, right? So I do the ping. One line is ping CNN.com with the IP address. 64 bytes is a line. Ping is a line. Packets is a line. Round trip. So this is the latency is a line. So again, if I'm creating this app and all I care about is latency, so this is the only line that I'm going to care about. And so I look at this and I say, what in this response is different per line? What is in this that isn't in other things? And so I sit here and I just go, I mean, you could do it on round trip. Round hyphen trip is unique. Again, I just do the backslash. So I could do, right, I could do ping, type it through grep, and then I could do round hyphen trip, because that's unique to that line. And then when I do that, all I'm getting back is that one particular line. So basically that's all that grep does, is whatever you're querying for, it will return the entire line where that is, so you can do something with it.
Okay, I thought it could pull more information about the server using the command grep, but I guess not.
No, this is all that grep does. Again, you can use a command that gives a response back about, again, your IP addresses or top. I think top might be that. So, let's do clear. Clear. So we can do top. So top is the task manager of the Linux world. Right, so again, you look at a whole bunch of stuff. So processes, we got 752 going on. CPU usage is this. Mem regions, all that kind of stuff. So if I take a look at this, let's say all I care about is CPU usage. So what I could do is I could do Control C and I could do top. And then I pipe it through grep. And then I could do CPU usage. Hopefully this works. Come on. Okay, so now all I'm getting is CPU usage. I'm not getting the rest of the information. Yep.
So that's what I was kind of figuring out. Like, grep can be used to pull information out about what the computer and server is doing, but you just have to know, you have to first get a bigger aspect of what you're trying to find, and then use grep to kind of like shave down the other information, get that one piece you want.
Yeah, so you find the tool that responds gives you a response in text, and then you can use grep to basically read through that response to find exactly what you're looking for.
And parse it out like you mentioned before.
Yep.
Thank you.
There you go. Blah, blah, blah. Okay, so that's what grep is. Now with grep, and I see somebody in here talking about string, so you can do regex in grep. Regex is painful enough. RegEx is painful enough. One of the things I think about with regex, I did not put it in there. Is it down there somewhere? Anyways, somewhere in this, is so regex, and basically pattern matching can be used in almost any programming language. So whether you're using JavaScript, whether you're using PHP, whether you're using C#, whether you're using Python, whether you're using grep, you can do this whole pattern matching thing. The big thing to understand though with pattern matching is it's different for every programming language. Every programming language kind of does regex the way that programming language does regex, and so you can do pattern matching with grep, but we're not going to get into that today. Today's gonna be painful enough. We don't gotta add regex to our grep. This is just kind of showing you a way to kind of clean up the data that's coming in. Beyond that, we can do simple matching with something called the split method. So whenever we talk about methods in the Python world, method is essentially like a function that tweaks variables. So upper will make all of the characters in a variable uppercase. Lower will make all the characters in a variable lowercase. So what split does is it turns a string into a list, and you can split it based off of whatever character you care about. So you hear about CSV files, comma-separated value files. What you can do is you can pull in a line from a CSV file. You can then do a split based off of wherever the commas are, and then that is the value for your records. And so that's one of the ways you can parse through things, right? So split will turn a string into a list. You use a separator that you assign. So split, basically what you do here is you do a single quotation mark, a space, and another single quotation mark. That will split at every space. So if you have a big document and you want to turn every word into a value of an index for some reason, you could do that. Again, if you have a CSV file, you can split based off of a comma. If you have tab, you do a split off of a /t, whatever your separator it is, whatever. The thing that's nice about this is basically what we can do is if we're trying to go through, and let's say we're trying to find things like IP address or email addresses, something like that, where we know we have something that basically we can trigger off of to try to clean up the data. Basically, we want to get rid of all of this. We want this. What do email addresses have that the rest of this crap doesn't have? They have the @ symbol. So basically, hey, what if we can turn this into a list, and then I can pull out the only thing that has an @ symbol to it. So let's see here. So basically, we have an example at the end. But let's say we have this message, right? So message equals my email address is bob@bob.com. So that's the full message. What we can do then is we use split, right? So basically we say message. So message equals message.split, and then we split it wherever there is a space. So it'll split on my, it'll split on email, it'll split on address, it'll split on is, so on and so forth. So then we print out the result for that. We're now going to see that we have a list. My at index 0, email at 1, address at 2, is at 3, and bob at 4, right? Then what we can do is we can simply iterate. We can iterate through that list. And so we can say for word in message. So message is now a list. So for each index in message, we're going to iterate through. And then we're going to say if the @ symbol is in the word, we'll print that word out. So it'll go to my, nope, email, nope, address, nope, is nope, bob at, yep. So it'll print that out, and it will give you bob@bob.com, but that's going to give you that period at the end. That gets a little ugly. So one of the things you can do is you can then clean it up with, again, the strip method. Basically what the strip method does is it says remove any of these things. So remove periods, remove parentheses, or remove commas. And then we'll print the word out, and then you get the clean word right there. So we have an example here on split.py to kind of show you how this works. Okay, so let me comment that out for a second. Okay, so basically we have a string. Oops. String. Hello, this is Bob at bob@bob.com. I'm contacting you on behalf of my friend Tom, who is at tom@aol.com. Cindy at gmail.com gave me your email address to contact you. You can ping me on LinkedIn at Bob or at Cool Dude. Right? So this is kind of how like email scraping works. You know how you plug your information in like to a document or something, and all of a sudden you start getting a lot of spam. Basically, we're about to show you how that works in the real world, right? And so basically start looking at this, and basically what do I want? Again, from a very simple standpoint this time, just to kind of show you what this kind of technique does, is basically I want anything with an @ in it, right? So basically email addresses have ats in them. So bob@bob.com, tom@aol.com, and Cindy at gmail.com. The issue that you do run into though is again with modern social media, the @ symbol can be used for social media. So we also have @Bob and we have @CoolDude. So anyways, so what we're going to do is this is a string, we're going to split the string and then we're going to print out what that looks like to begin with. And so we do that, we can now see the string we now have turned into a list. And so since it's now a list, we can simply iterate through the list to look for the specific things that we're looking for. Let me do that. Okay, so now what we're going to do is we're going to iterate through the list for word, and so basically for each index in the list of string, if there is an @ in the word, we're going to print out that word. So we're going to go through, and now we got Bob at bob.com with a period. We have Tom at AOL.com in parentheses with a period. We have Cindy at gmail.com. That's actually clean. We have @Bob. We have @CoolDude. So this kind of gives you the ability just to pull out that specific information, but it still looks pretty ugly. So then what you can do is basically you can use that strip command, or the strip method. So word.strip, we'll strip out the periods, we'll strip out the parentheses, we'll strip out the commas, and now when we run this, we get something that looks a lot cleaner. Bob at bob.com, Tom at AOL.com, Cindy at gmail.com. We still have the @Bob and we still have the @CoolDude. But again, this cleans up the data, so that's a hell of a lot easier for the next stage to be able to deal with. And you don't have to use regex or anything like that in order to be able to pull this type of information out. So this is the basic idea with being able to use split and then being able to iterate through a list looking for the specific type of information that you're looking for. So again, if this had I don't know, if it had MAC addresses in it, you could try to pull out based off of colons. If it had, I don't know, IP addresses in it, you could try to pull out based off of periods. That would probably be a little weird, but that's kind of like a basic idea of something you can do before you get into the world of regex. David, what's up?
Hey, so how come it didn't remove the period between Bob and .com and AOL and .com?
Okay, because when you use strip, the nice part about strip is it strips from the ends. I guess I should explain that with method. So whenever you use these methods, so there's a lot of different methods. There's lstrip, there's rstrip, there's replace. So how they all work is their own special thing. But basically with strip, what it does is it removes the period, the parentheses, or the commas from the end, not from the middle. So I don't know. If I did this, yeah, see those don't go away because they're in the middle. So it's removing them from the front, from the back, or from the front.
Gotcha. Thank you.
And that's a lot of this stuff with like methods and all that kind of thing. Is you just play with it to find the one that works best for the specific task that you're trying to accomplish. And it can get confusing. It can get confusing. One of the reasons why regex actually can be pretty useful at the end of the day. Okay, so we get to regex. Regex stands for regular expressions and is used to find text that matches patterns within strings. You can use this to pull out IP addresses, email addresses, phone numbers, etc. All languages. I always have to put parentheses or asterisks on everything because I don't know, maybe some language doesn't allow it. Basically, allows you to do regex, but the patterns may be different. So that's important. So again, you're going to be going over to JavaScript. You're going to be going over to PHP. Check ChatGPT before you go over there. Again, I will say that again. ChatGPT is not intelligent. It is not artificial intelligence, but it is still very useful. Again, if you're trying to figure out how to create regex patterns or whatever else, it is an incredibly useful tool to say, hey, can I get a regex pattern for how to pull out email addresses? And it actually will give you one that hopefully should work most of the time. When you're using Python, again, everything in Python, you have to use a module to get anything accomplished. So with Python, the module you're going to be using is RE. That's it for regular expressions. It should be installed into your environment by default. If it's not, Past that, we then have a couple of functions that come out of our regex. So it's not that you just use regex, you have functions that you need to use. So the first function, probably the most important function that you're going to use, is going to be the findall function. And so what the findall function is going to do is you're going to feed it a pattern. Again, we're going to talk about patterns a little bit later, but you're going to feed it a pattern. This actually means something. And then basically, your response is going to be re.findall function. You're going to feed it the pattern, then you're going to feed it the string, and then it should give you a list response of everything that matches the particular pattern. So if we go to the findall, we can just take a look at this real quick. So this is what we're looking at. So this is the pattern up here. So we'll talk a little bit more about patterns, right? When we get to the pattern part, but this is what a pattern looks like. You're going to have R to begin with, with F strings. So we do concatenation, we use Fs. So whenever you're using regex, you need to use R. What R does is it turns it into something called a raw string, and therefore Python ignores some of the text formatting commands, so /n/t, some of the other text formatting commands that exist. It ignores that because you're not looking for that, or you might be looking for that type of thing, right? So if you do /n without the R, basically it might cause you problems. Anyways, you do the R, so you put it in as a raw string. So that string goes in raw and pure into the Python environment, and Python doesn't screw with it. It's like VIP. Python it's just allowed through. Nothing weird happens. You then put the either single quotation marks or double quotation marks around it, so that encapsulates what the entire pattern is going to look like. If you take a look here, basically what this is for email addresses. The brackets, basically what the brackets say is any one of these types of characters. So basically you can put in 0 through 9, A through Z, you can put a whole bunch of different characters in there, but basically say any character that matches one of these things. The /W here, basically what /W is going to mean is any word character, B-O-B-A, whatever. Not at, not period, those are non-word characters. So /lowercase w is a word character, alphabetical character. Then you're going to see period, but you're going to see a slash in front of the period. So this is where we need to escape within Symphony IT. This is where we need to escape within the regex pattern itself, right? So we're outside the Python world. We're flying free outside of Python, but we still got rules. We got regex rules now. And the thing is, in the regex world, periods mean things. Periods are a wild card for a single character. But we don't want that, right? We might have like bob.billy@AOL.com. So period might actually be part of the first part of the email address. So not only do we need normal text characters, word characters, but we also might need a period or we might need a hyphen. So /period, what this is going to do is it's going to escape add the period so that we're just looking for periods. It's not some weird ass wildcard. And then we're going to do a hyphen here. So basically any word character, a period, or a hyphen. You do plus at the end of this. And basically what that means is any number of those characters, whether it be one or whether it be a gazillion, any number of word characters, periods, or hyphens, blah. Then we do plus @. So again, if we're doing an email address, @ is part of that. So we go any number, @, and then we basically do the same thing here, where it's the bracket, any word character, period character, or hyphen character. Right? Then we do plus, so basically any number of these. Then we do period, so again we escape and we do period. And then we do plus, any, like here, again, whether or not this is the best one for email addresses. But anyways, so this is any word character, so com or whatever, edu or mil. And then we do squiggly bracket, and we put a number in here, and we say a specific number of these. So plus means any number of those. Squiggly bracket means a specific number of these. So we want three of whatever. So com will work, mil will work, edu will work, info will not. And this is one of the things you have to be careful about. Again, test with things like your regex is what happens if somebody puts an IO in here. Did you put 3? So basically here, and we'll talk about it later, you can do a minimum and a maximum. So you could put a minimum of 1, a maximum of 4. And so IO would work, info would work, right? But if you just put 3, what that means is .io will not work. Nor will .info work, because that's 4 characters, right? Get into a bit of an issue. Let's see here. Jock, what's up?
This is kind of like a dumb question, but shouldn't, maybe I'm wrong, but in the first part, when inside the brackets you got words, periods, and slash, shouldn't we also add numbers to that first part before the @ symbol? Because a lot of times email addresses have numbers as well. Is that possible to use regex for that?
Yeah, we'll get there. We'll get there.
Oh,
This is just this very simple example. Very simple example. Yep. Let me get there. Anyways, we're just doing a basic thing right now. And so this will be able to pull out Bob at Bob, and I'll be able to Tom at AOL, and Cindy, blah. So anyways, what we're going to do is we're going to say response. Really what we care about here is this findall. What we're doing here is findall. So response equals RE for a regular expression, findall, basically the pattern. We're going to feed it this particular pattern. We're going to feed it this text, and then it's going to spit out the response. All right, so when we do this, it will then give us Bob at bob.com, Tom at AOL.com, and Cindy at gmail.com. So that basically pulls out those 3 specific email addresses for us. And you'll also notice that it's clean, right? There's no, I think, let's hope this will happen there, actually. Yeah, that's clean. Whew. Oh, doing live demos makes you scared, right? So since I'm looking for a specific pattern, right? So Cindy at gmail.com, like when I pull this out, I didn't allow for parentheses. I didn't allow for parentheses up in my pattern, so those parentheses were not brought in, so I didn't have to do any additional cleanup work once they were brought in for that. And so that's basically what you're doing with the find all function is you're looking for all instances where this pattern shows up within a string. Again, this string might be 1,000 pages, and then you're pulling out that specific information. Let's see here. We have match. So match basically checks if a pattern is at the beginning of a string. You use group to print out the word that matches the pattern. So this is a weird one. Like, it exists. It exists. If you actually use it, I don't know, maybe it's useful. So the idea here is you create your pattern. So here we just have hello. And all this is going to do is it's going to say, does this pattern match however the hell this particular string starts? So you do match equals re.match. So basically, again, you use a match function. You put in the pattern, you put in the text. If match is true, so basically when you run this, it'll either be true or false. So you can simply say if match, so basically that means if is true, print match found. Match.group, and so what this is going to do is going to tell you the word that is matched, else print no match found. All right, so basically if you do this, it'll say found hello. I think if I do period, that should work too. Yeah, found hello. Right, so basically, and again, when we're talking about these patterns, we'll talk about some of these characters in the future, but so we're saying this pattern is HE, period means wildcard for 1 character, period means wildcard for 1 character, and then O. So I want anything with hello in it, right? So I could do, I don't know, Heppo. Man. All right, and so I do that, and I'll say, yep, we found Heppo in the beginning of the string. That's all it does, right? So if you do like world, so basically world, this is not if it's in the string, it's just if it's in the beginning of the string. So if I do that, basically what you're going to see is no match found. So basically world is not in the beginning of the string, so therefore it fails out. How much you will use match, God knows, but it does exist. Let's see here. Then we can do search. Search is kind of interesting. Basically what it does is it finds the first occurrence of something. So again, group, as I showed before, basically that shows you the word that was actually matched. Start shows you the character position of where that particular character, that particular word started. And end shows the position of the ending character. If we do search, this is basically what it looks like. Right, so we import, then we create this pattern here, and again, this is a little bit different for email addresses. /w, period, hyphen, plus an @ w, hyphen, period, plus a period, plus any word, so any letter character between 2 to 6 characters. And so it'll go through and basically it will find the first one that matches this pattern. Hello Bob, how are you? I was told your email is bob@aol.com. Is this right? My email is tim@gmail.com. You're going to put this through, so response equals re.search. You're going to plug in the pattern, you're going to plug in the text, you're going to print out what the response looks like just so you can see it. Then we're going to say print response group, so we're going to print out the word itself. We're going to print out the character that it starts at and the character that it ends at. And so if we run this, basically what we see is that we get an object. If all we do is print out just the result, you're just going to get this object, span 65, match equals bob@aol.com. So we do group. So group gives us bob@aol.com. This starts at character 65, it ends at character 76. But one of the things you'll notice with search is that only does the first time the pattern is matched, not the additional times that a pattern is matched. And so that can get you a little screwed up. Again, generally you're going to be using findall. Findall is the function that's most useful, but this one also exists too if you're looking to see if a document might contain specific information. Let's see here. So that's search right there, and then we have substitution. So substitution can actually be very useful. Again, we start talking about like modifying input text. So this is important too. Again, the data that goes into your database is going to be very important. Garbage in, garbage out. Ugly is crap in, ugly is crap out. Like one of the problems you're going to have, right? You're going to have user inputs. And so think about something as simple as a telephone number, right? How does the average user plug in a telephone number? Do you do 111-222-3333, all as one thing? Do you do 111-222-3333? Do you do 111 space 222 space 3333? God knows what else that you do, right? So again, imagine if you're trying to pull out things like telephone numbers, you're trying to put them somewhere, and then you're trying to clean them up. Basically, with regular expression, with the sub function, what you can do is you can put in a pattern that you're looking for, and essentially you substitute, you replace it with whatever it is you want to replace it with. Right, so we have a telephone number here, 111-222 space 33333. Right? So basically all you do is result equals re.sub pattern. So if we see a hyphen or we see a space, we want to substitute any hyphens or any spaces that we see. We're going to substitute them with nothing at all, and we're going to replace that in number. So the pattern is here, what we're replacing is with here, and the string that we're doing this on is here, and then we print out the results. Oh, so when we do it, we see we now get before we had this mess, and now we get 111-222-3333 all in a nice little block. And so this is something you can do. Again, we were talking about before, and that whole thing with validating and sanitizing the data that is coming into your systems. This is one of the ways that you can try to clean it up so that it looks better for whatever it is that you're trying to accomplish. Christopher coming in at 252. Hey. Come on in. Come on in. Class is close to being over, but you showed up. You showed up. Let's see here. Okay, so now let's talk about the characters and the patterns. All right. So again, as we talked about before, so R equals raw strings. This is going to disable certain text formatting rules for Python. When you need to escape characters within your regular expressions, you're going to use backslash. So again, black, backslash, period, backslash, something like that. You're going to use that to escape out. And basically, there's a whole bunch of different characters that you can use in order to create your pattern. And again, this is one of those things, a lot of trial, a lot of error, and going to ChatGPT and saying, no, but seriously, what's the damn pattern? So if you have a period, matches any single character except a new line. If you do the upper arrow, the little hat thing, matches the start of a string or line, right? So basically if you say, I need something to, the right thing to begin, right? So you do the little hat thing. The weird part though, is if you do the hat inside the square brackets, then it means not, which again gets into the stupidity. So anyways, hat outside of square brackets means it has to start with this particular pattern. Hat inside square brackets means don't trigger off of any of these. Dollar sign matches the end of the string. Star matches 0 or more occurrences, so nothing or something. Plus matches 1 or more occurrences. Question mark matches 0 or 1 occurrence. Squiggle mark in matches exactly in occurrences. In, comma something matches in or more occurrences. NM matches between N and M occurrences. The brackets defines a character set. And so that's where you can do A through Z, A lowercase through Z, A uppercase through Z, 0 through 9. You can put all that in the brackets. Whatever that does. Groups, characters, or expressions. So basically use parentheses, and you can say all of this. Again, I'll kind of show you some examples here. Then we have here where you can put in like those slash D's or slash W. So slash lowercase d matches any digit between 0 to 9. So it's the equivalent of this. Uppercase D matches any non-digit. And this is where it gets really confusing. So basically it matches anything that's not 0 through 9. See that little hat there? So basically it says don't match that if you do uppercase D. Lowercase w matches A through Z, uppercase A through Z, 0 through 9, or underscore. So that's what lowercase w does. Uppercase W says don't match any of those. Lowercase s means match any white space. So that's either a space, a tab, a new line, and other white space type stuff there. Let's see here. Non-space character, start of a string, blah, blah, and word boundary. So this is useful. Slash B matches a word boundary, so you can kind of say where a word or wherever the pattern is should begin or end. Again, this is just playing with it. So, okay, so can I increase the, damn it. Alright, so let's go here, take a look at the patterns. So these are some patterns to kind of give you an idea sort of how this can look, right? So if we're looking for a MAC address, so the MAC address, if you haven't seen MAC addresses, it's the ARP-A. So the MAC address is a globally unique address for the network adapter on your computer. Again, you know how the tinfoil hat conspiracy theorists that are going to be at your Thanksgiving dinner tomorrow are going to be like, oh my God, the government wants to track our computer. The government wants to put a serial number on every single computer. The government doesn't want to do that. It did it. It did it decades ago. This is called a MAC address. It is considered a universally unique identifier. Half of the identifier is the vendor for whoever manufactured the network card, and the other half of it is basically a serial number to identify which number it is. Basically how the Ethernet standard works, these all have to be globally unique. There should not, again, there are ways to do it. There's something called MAC address cloning. We're not going to get into it, but these should be 100% unique. So anyways, let's say I want to be able to pull out the MAC addresses. So again, let's say I'm doing inventorying of systems on the network. I want to be able to track how these systems are going, right? Since it's an absolutely unique identifier, I want to put this into my database as the unique identifier for all of the different systems, and then be able to plug information. So anyways, this is what it looks like. This is called a hexadecimal number. So it's 2 digits, or it's between 1 to 2 digits, and then you got the colons in between. So it's 8 of these. Right, or it's 1, 2, 3, 4, 5, 6. Sorry, 6. 1. Yeah, it's 6. Anyways, it's 6 of these. It can be 0 to 2 numbers, the whole 9 yards. Anyways, so we take a look at it. If we were trying to pull out a MAC address, we would get something that could look like this. All right, so we start with a bracket. We start with so we start with the parentheses. So we say all of this is going to be like one thing. We'll get to that in a second. So we go with the bracket. So we say 0 through 9. So the digit here can be 0 through 9. It can be uppercase A through F or lowercase a through F. So when you come up with a hexadecimal number, it's A through F with a 0 through 9 digit, and that gives you a hexadecimal number. Right? So it can be any one of those. Then we say 2. Did that come out right? Actually, that should be 0 or 2. Or that should be 1 or 2. Sorry, these are all beta classes. All beta classes. So there can either be 1 or 2 of these, right? Then we're going to have the bracket, and we're going to say either a colon or a hyphen. So when you pull out, when you do that ARP -A, depending on your operating system, those hex numbers may be separated either by a colon or a hyphen. You might not know what you're getting. So we're going to say either a colon or a hyphen. So 1 to 2 characters separated by a colon or a hyphen. That is going to be for one of those values. Now again, it's 6. It's 6. So it's number, colon, or hyphen. So we're going to repeat this 5 times. Again, whenever you get a MAC address, it's always going to be 6 of these patterns. So we're going to repeat this 5 times. We're going to look for that. Then we're going to come here. We basically got the same thing. 0 through 9, A through F, and then 2. Right, so that's the end. So if we take a look at this, right, so we got the hex number here, and so basically we're going to say we want the hex number with either a colon or a hyphen. We want that to be repeated 5 times. 1, 2, 3, 4, 5. Right, so that's basically what we're looking at. And so then the final one doesn't have a colon or a hyphen. So that's why we're putting that on the end as its own little lonesome there, and that should be able to pull out a MAC address for you. So that's something like a MAC address pattern would look like. If we take a look at an IPv4 address, so here, so we use the bounding on this, so maybe we don't get weird stuff. We don't get like, I don't know, things we might not want. So with this, you do /B/B, and so this puts a boundary around this particular pattern. We don't want any additional information that might be on this. We don't want port numbers or things like that. Again, we're doing this for the set. So we say /D, so basically we want a number. We want 0 through 9. Oh, Christopher, what are you doing? Christopher, it's 302. Anyways, so we want a number, 0 through 9. We do the squiggly bracket. We want between 1 to 3 of those. It has to be 1 to 3 of those. We then escape out of the period, because we don't want this to be a wild card. We want it to be a period, right? So we do 1 to 3 numbers with a period. That's all within this set. And so we say we want 3 of these. And then for the final one, we then say we want, digits, 0 through 9. We want 1 to 3 of those, and that should be able to pull out an IP address for you. Now again, to be clear, we take a look at this. This is not a validated IP address. So one of the things you have to think about is God help you, how ugly is your data? But seriously, how damn ugly is your data? All right, so if you look at this, you're following along at home, you'll notice all this is looking for is between 1 to 3 digits, blah. So if you know how IP address schemes work, you know generally it basically can be 1 through 254. So you can't have an IP address of 300.500.64.999. That's not how the address scheme works, right? You can have 192.168.1.1. One of the things you have to think about with your patterns is just how ugly is your data. So if you're pretty sure, right, you're doing ping commands, you're dealing with log files, then most likely, again, the IP address data that's coming in, it should be nice and clean, and basically you can just do this pattern match and you should be fine. If you're doing things, if you're getting like IP addresses like directly from users, so you're asking the user for an IP address or something like that, and they might put 554.337.666.1 as an IP address. You may want to make this a hell of a lot more complicated so that you can actually validate that the IP address is within the scheme that it's supposed to be within. But then again, that starts to get really ugly really fast. So again, that's kind of one of those things you have to be thinking about. Is like, again, how clean is the data that you're going to be getting? Again, for an email address, again, if you're going to bound this is a little bit better for email addresses. So A through Z, uppercase, A through Z, lowercase, 0 through 9. Oops. That should be a backslash in there. Oh, again, you're doing the... Yep, those should be backspace. Anyways, so A through Z, 0 through 9, period, underscore. Theoretically, I guess you can have a percent sign, you can have a plus sign, you can have a hyphen. So basically any one of those characters, any number of times, with an at, again, 0, Z through A, 0 through 9, that doesn't have some other stuff there. Anyways, plus however many of those, then a period, then A through Z, 2 to however many of those, /B, and that should get you some email addresses. Again, I don't know if you could actually have numbers in there. I would check on that one. So anyways, that's one of the ways you might be able to do a pattern for an email address. If you're looking for something like a social security number, again, we're going to do the boundaries for that. Digits, so 0 through 9. I want 3 0 through 9s with a hyphen, with 2 0 through 9s with a hyphen, with 4 0 through 9s and end, and that will give you a social security number, hopefully. And so that's basically what we're talking about when we're talking about the pattern matches. And yeah, I mean, basically at this point, you should definitely know at this point how to create a little file like this, import, regex, import re, create a nice ugly ass string, and then you can just sit here and start plugging in patterns and see how that works for pulling out the specific information that you're trying to pull out. This is very much one of those trial and error things, looking at the data that's coming in, how clean that data is, and trying to figure out how to deal with it from your end. And wow, it's amazing. It's amazing how fast you can go when something's painful. So yeah, that's basically the RegEx class for you. Again, it's just a lot of trial and error and figuring things out. Again, the substitution is a very useful function for RegEx. It's because, again, you can go in and you can try to clean up text that's coming in. Again, format it in the way that you want it formatted. And again, I would argue findall. Findall is really the function that you're probably going to be using, because this allows you to find all instances of something that matches your pattern and then be able to dump that into a list. And yeah, that's it. And then ChatGPT is your friend. ChatGPT is your friend. It's not intelligent, but can still be a friend. I don't know. So anyways, there you go. That's the class for today. Any questions? Any questions? Is there a meta character command for finding duplicates? So with duplicates, you could create, which set is it? So you're talking about sets. You could say if it's already in there, you could build something. You could build something. Basically, if it's not already in the list, add it to the list. You could do append. Or you could change it. What's a set? So you got lists, you got dictionaries, you got sets. Is it a set? You got tuples. Might be a set. A set is a data type that looks like a list, but you can only have one instance of any unique value in it. So if you changed a list into a set, that should get rid of duplicates for you. I would have to sit down and figure out exactly how to do that one. It shouldn't be hard. It should be like 2 lines of code. I'm just not exactly sure the 2 lines of code. Oops, somebody had their hand up. Somebody had their hand up and then went away. Anyways, I'll ask ChatGPT. There you go. There you go. Okay. Any other questions? Any other questions today? No other questions. You're all quiet. You all are quiet. All right, really, that's it? All right, cool. That's easy. Get a start on Turkey Day. Get a start on Turkey Day. I've got to do, we're doing the turkey trot tomorrow. If you're here in the Asheville area and you've never done the turkey trot, it is an amazing experience. So it's a 5K, it's a 5K run. I know it sounds a little, but that's the thing. You wake up in the morning, you go out, there's like 2,500 people. There's between 2,000 to 3,000 people in Asheville that go down to the turkey trot, and then you just run in this big mass of people, and then you come home and you eat Thanksgiving dinner. It's a great experience. So if you're here in Asheville, definitely take a think about going to the turkey trot. I've got to go get my shirts and all of that kind of stuff. Yeah, so that's it. That's it. So I will be, again, like I say, if you're in the Raleigh area, the Durham area, I suppose, I'll be at that All Things Open meetup next Tuesday in the area. And yeah, that's all I got. That's all I got. Any questions? Final question. Oh, Akeem. There we go. Oh, see, this is what happens when you're late. Hey, Akeem! Great to see you, Akeem. Yeah, like, we're literally ending class. We're literally ending class. You literally walked into class as I was walking out of class. So good news, you will not fail. Simply because I do not give grades. But it might not be the best for your professional development. Walking into the end of classes, just because you showed up, doesn't mean you're actually going to take anything away. But anyways, you all do you. The nice part about you not failing is I don't have to worry about you not failing. Anywho, okay, that's it. That's it. Cool. See y'all later.